Okay, so now I'm going to talk about some of the trig identities about how to sum angles together. So the sum identities for trig. And in this one I'm going to talk about the sum identity for sine. So what does it mean? Well, we already have right triangles and we know what sines and cosines are. But then, so we know so here now we have an angle alpha and then here we have an angle beta. And so we sort of put these two triangles together, and so this whole angle is alpha plus beta. And one of the reasonable questions to ask is, well, we know what sine of alpha is, we know what sine of beta is, we even know what cosine of alpha and cosine of beta are. But then what is sine of alpha plus beta? Is there some way of getting this without just saying sine of alpha plus beta? Is there a way to express it in terms of just sine and alpha and sine of betas? And of course, there turns out that there is a way. So how do we actually get the sine of this big triangle? Well, let's first just label this. So let's label the hypotenuse C, and then let's label this entire edge here A, right? So this whole edge length is going to be A. Okay? So now how do we actually go through and find it? Okay. Well, so sine of alpha plus beta is going to be the ratio of A divided by C. The problem is we don't actually know what A is, right? Since we only know the sine of alpha will give us this thing, and here this is not even a right angle, this is an obtuse angle, so we can't even use sines and cosines to get this edge. So, how do we do that? Well, one of the tricks is this is not a right angle, so one of the first things to do is to extend it so that it becomes a right angle. So let's extend this triangle until it becomes a right angle. So here it's obtuse, but we continue to shift it over until it becomes a right angle, and we extend it that far, right? And similarly, we can drop down, this one here. Okay. So now let's look at the length from this vertex to this extended distance. This length. So okay, so from here all the way to there, let's call this one D. Okay? So D is not to here, it's all the way to here. Okay? So let's call this one D. Well, this is a right triangle. D is the adjacent side to this angle beta, and C is the hypotenuse. So that means that D divided by C, okay, that means that D divided by C is cosine of beta, right? And of course this simplifying algebraically gives us that D is equal to C cosine of beta. Okay, now similarly, what about this bottom one, B? All the way from here to here, not to here, but to the end of this extended right triangle. So originally this was a right triangle, but we extended it past here so that it connects with this vertex as a right triangle. Okay, so then what is that? Well, here we have another right triangle with D as the hypotenuse and B as the adjacent side. Okay, actually, we're trying to find sine, so this is actually going to be the cosine of it, but yeah, so let's not find this length, let's find this length here. Okay, but it's the same concept, so B is the distance from here to here. So now we have a right triangle with the hypotenuse as D, and B is the opposite side to the angle alpha, right? So that means that by definition, B divided by D, the opposite over hypotenuse, is going to be the sine of alpha, and that means that B is going to be equal to D times the sine of alpha. But D was already equal to the C times cosine of alpha, so we can actually substitute that in for D, and this gives us that B is going to be equal to C cosine of beta times the sine of alpha. So just substituting in D for C cosine beta for D, and then we'll get that this length B here is C cosine beta sine alpha. And then you can sort of see this from the diagram. It says that Okay, I know this length c. Now to find the adjacent side here, I multiply it by the cosine of beta, and now using this as a new hypotenuse to find the opposite side, I multiply it by the sine of alpha. So it's like a progression. Here, multiplied by cosine beta gives us this length, multiplied by sine of alpha gives us that length here, b. Now this only gives us, this part of the length, right? We actually need this whole length here from the top to the bottom, and that's, the opposite side, so we need to find that. So what's missing is that we have all of this distance missing to the top here, right? To the top there. So we have this distance missing. Okay, so how do we actually find this distance? Well, first let's do some geometry. One is that this is alpha, so this is going to be 90 degrees minus alpha. And now this is going to be a opposite angle to this. So in geometry we know that opposite angles are equal, right? Because this one plus this angle is 180 degrees, and this one plus this angle is 180 degrees. So these two must be equal. So this one is also 90 degrees minus alpha for this angle. But this was the right triangle that we created here, right? So this angle here must be 90 degrees minus alpha, which makes this angle exactly equal to alpha. Right? So we have a new right triangle here with this angle equal to alpha. Okay? So that's fine. So then that means to find this distance, we kind of want to drop a straight line from here to here. And so a horizontal line. So because this was a vertical line and this is a horizontal line, this exactly makes 90 degrees, and we get a right triangle here. And the question is, well, let's find, this side of this right triangle and what the length of it is, and that's the remaining length. Well, but this thing is just okay. So that means that if we know this length, the hypotenuse of this small right triangle, then we can find this length by sines and cosines. But we actually know this length because this is actually the opposite side, because this here is also a right triangle, this one here. So this opposite side is just going to be c times the sine of beta is going to give us this opposite side, right? So I'll let you work through the details, but going through the same steps, saying the opposite divided by c is sine of beta, that means this length here is going to be c sine of beta. So this length of this side is going to be c sine of beta. This one divided by this one is going to be sine of beta. So now to find this length, we know the hypotenuse is c sine of beta. This is the adjacent side to the hypotenuse. Okay, so let me just write this down. So here, let's label this one as D, and let's label this as E. So, let me just write this down. So B was C cosine beta sine alpha. Okay, so now here we have E, we have C sine beta, and we have alpha. So this means that, here's the right angle, so adjacent over hypotenuse, E divided by C sine of beta is going to be equal to the cosine of alpha, and this means that E is going to be C sine of beta cosine of alpha. So this length E is going to be, so this is the same length as here, just translating it over. We C sine of beta cosine of alpha. Okay, and now, what was the sine of alpha plus beta? Well, that's exactly just this adjacent side length, or the opposite side length, divided by the hypotenuse, right, of this triangle. So the opposite side length is going to be this length plus this length. So sine of alpha plus beta is going to be equal to the ratio of this whole side, which is going to be this thing, so C sine beta cosine alpha plus this length. And this thing I copied it wrong, because there should be a C up front. Okay, so plus C cosine beta sine alpha. And this whole length should be divided by the length of the hypotenuse. And because there's C in common for all of these, we can cancel them out. And so this just becomes sine beta cosine alpha plus cosine beta sine alpha. And let's start writing. We get sine beta cosine alpha plus cosine beta sine alpha. And this is, the sum identity for sine. And normally, because the beta and alpha are switched around, people normally write it the other way, just so it's easier to express and remember. And you can think of it as, sine alpha cosine beta plus cosine alpha sine beta. So it's just switching these two terms around and then switching the insides terms around. And so, so this is the sum identity for sine, and this shows how to derive it. And it just says that sine of alpha plus beta is sine alpha times cosine beta plus cosine alpha times sine beta. So it's sort of easy to remember, because you have a plus b, and then you do like sine, cosine, cosine, sine, add them together, right? Sine first one, cosine second one, plus cosine first one, sine the second one. And that is the sum identity for sine, and it comes in handy. And a lot of times when you're dealing with some expressions in sines and cosines.